All right, we got another one where we are going to graph a rational function. And again, you're going to kind of do, it's nice to factor things first and get things kind of a little bit, oh my goodness, a little bit organized for yourself to start with. I'm trying to, I don't know why I try every single time to put the wrist guard up there so I don't end up messing up the video, but whatever. All right, so your numerator actually factors, I'm going to do it up in the upper right hand corner, it actually factors into an x plus a 4 and an x minus 3, right? Because two numbers, when I multiply them, I get negative 12, and I add them, I get 1. And then your denominator doesn't factor at all. And so if you notice, then nothing cancels. Okay, nothing cancels, so there will be no holes in this rational function. So to find your zeros or your x-intercepts, you take your numerator, set them equal to 0, set your numerator equal to 0. I already factored my numerator, so I know that each factor can equal 0. So I get x equals a negative 4, and the other one will give me x equals a 3. All right, so I've got that. Vertical asymptotes. You always take your denominator and set that equal to 0. 2x equals 0, so x equals a 0. So we have a vertical asymptote at x equals 0. Again, you check your, what else do we have? Zeros, a horizontal asymptote is next. Ultimately, when you're looking at this, okay, x squared over a singleton x squared over a singleton x, that is when you do not have a horizontal asymptote. No horizontal asymptote because you have a higher degree in the denominator, or I'm sorry, in the numerator than you do in the denominator. In fact, you have 1 higher in the numerator than you do in the denominator, so that means you have a slant asymptote, okay? And there are a couple ways you can find that slant asymptote. I'm actually just going to do a real quick long division, x squared minus x minus a 12. All right, so when I'm doing this, 2, sorry guys, 2x goes into x squared. Well, technically it would be an x, right? And so then I'm actually going to have to, write this as x here. But I need, when I do this, I need x times 2x. I need that to be a 1x squared. So what I'm going to have to do is stick a 1/2 in front of that. And so then when I actually go and distribute this, 1/2 x times a 2x. Well, 1/2 times 2 is 1, and x times x is x squared. So then I can subtract that, right? And so that's going to go away. And so then I will just bring down, because it's basically just a 0 there, and then I will bring down this negative x, okay? And then I have to do kind of the same thing. The x times the x, well, that I don't need another x, but what I need here is a negative 1/2, because when I do this again, negative 1/2 times the 2x, negative 1/2 times the 2 is a negative 1x, okay? And so that's going to go away as well. So I actually have my slant asymptote is y equals 1/2 x minus 1/2. You could have also done synthetic division, but you got to remember that when you do synthetic division, you have to watch out for this leading coefficient. So everything else, the only other thing, everything else, it's all good. So let's then put everything that we need on there. So we've got zeros at negative 4 and positive 3. Got to switch over to the red, sorry. So negative 4 and positive 3, 1, 2, 3, there are my zeros. I have a vertical asymptote at x equals 0, so I have a vertical line on the y, a vertical dashed line on our y-axis. My slant asymptote, it's, again, a little bit rough because we're dealing with fractions and a very small iPad. So you start at negative 1/2, and then you basically go up 1 and to the right 2. So I'm trying to make them small and dashed. And then you go up 1 and to the right 2, and up 1 and to the right 2. And you can go down 1 and to the left 2, down 1 and to the left 2, and down 1 to the left 2. And notice, like, I'm actually putting my dashes in between the whole numbers because I started on a 1/2, so that's really where it needs to be. So there's your slant asymptote. Sorry it's not better. I need to actually probably make my picture, my graph bigger, but that's all right. And then we're good to go. You can go and put this whole equation into your y equals in your graphing calculator, and then you can zoom 6 it, and you are basically just responsible for sketching the shape after you've given us all that information, and that shape looks like this. Oops, there we go.